In the natural world, temperature is not simply a measurement. It is a force that shapes life itself, a silent boundary that decides where organisms can survive and where survival becomes impossible. Heat provides motion, energy, and growth. Cold removes all three. Slowly, quietly, relentlessly. When temperatures fall far enough, water turns into ice. And when water freezes, life begins to break down at its most fundamental level. Cells lose flexibility. Membranes become fragile. Chemical reactions slow to a crawl. And biological systems, once full of motion, begin to shut down. For most living creatures on Earth, extreme cold is not a challenge to overcome. It is a condition they cannot survive. But Earth is not a world defined by limits. It is a world defined by adaptation. And in the coldest regions of the planet, where wind moves like blades and oceans become endless frozen deserts, life does not disappear. It transforms. It adapts. And in some of the most extraordinary cases, it thrives in conditions that should make life impossible. Tonight, we enter that world, the world of animals that survive extreme cold, not by resisting nature, but by becoming part of it. To understand life in freezing environments, we must first understand what cold actually does to biology. At low temperatures, every biological process slows down. Chemical reactions lose energy. Enzymes become less efficient. Muscles lose responsiveness. Nerve signals slow dramatically. And water, the foundation of all known life, begins to solidify. But the greatest danger is not simply freezing. It is what freezing does at the microscopic level. Ice crystals form sharp, rigid structures. And as they grow, they tear through cells like glass breaking through fragile membranes. Once this damage occurs, it is often irreversible. For most organisms, this is the true endpoint. Yet in nature, extreme pressure does not only eliminate life, it forces life to innovate. We begin at the edges of the planet, the Arctic in the north and the Antarctic in the south. Two vast frozen worlds where winter is not a season, but a permanent reality. Here, temperatures can remain below freezing for months at a time. The ground is locked in permafrost. The ocean's surface becomes thick sheets of shifting ice, and sunlight disappears for long periods, leaving only darkness and cold. Yet beneath this frozen silence, life continues. One of the most remarkable survivors of the Arctic Ocean is the Arctic cod. At first glance, it appears unremarkable, a small fish in an enormous frozen ecosystem. But inside its bloodstream exists one of nature's most fascinating adaptations: antifreeze proteins. These proteins do not generate heat. They do something far more precise. They control the formation of ice itself. In normal organisms, ice crystals can form in body fluids and spread rapidly, destroying tissues. But in Arctic cod, antifreeze proteins bind to tiny ice particles and prevent them from growing. This means the fish can survive in water temperatures below the normal freezing point of biological fluids. It does not fight cold. It regulates it. It survives by controlling the physics of freezing inside its body. But the ocean is only one part of this frozen world. Above the ice-covered sea, another iconic survivor moves across a landscape that seems hostile to life itself: the polar bear. Polar bears live in one of the most extreme climates on Earth, temperatures that can drop far below what most mammals can tolerate, blizzards that erase all visibility, and unstable ice platforms that shift beneath their weight. Yet their bodies are precisely engineered for survival here. Their fur is not simply white for camouflage. It is a complex insulation system built in layers. The outer guard hairs repel water and reduce heat loss caused by wind. The dense underfur traps warm air close to the body, forming an insulating layer. And beneath all of that lies a thick layer of fat, which acts both as energy storage and thermal protection. Even more interestingly, polar bear skin itself is black. This allows it to absorb and retain heat from the limited sunlight available in polar regions. What appears white on the outside is actually a highly efficient thermal system hidden beneath the surface. A perfect example of hidden biological engineering. But the frozen world is not dominated only by large mammals. Beneath the ice, smaller organisms form the foundation of entire ecosystems. One of the most important among them is krill. Krill are tiny crustaceans that exist in massive swarms across polar oceans. They are the foundation of the food chain for whales, seals, penguins, and many other species. Despite their size, they are highly adapted to cold environments. Their metabolism is optimized for low temperatures, allowing them to function efficiently in water that would slow most life forms to a halt. They do not rely on strength. They do not rely on speed. They rely on consistency in an environment that rarely changes. As we move deeper into polar ecosystems, a pattern begins to emerge. Every organism here is shaped by cold, not randomly, but precisely, through millions of years of evolutionary pressure. On land, caribou and reindeer show another layer of adaptation. Their wide hooves act like natural snowshoes, allowing them to walk across deep snow without sinking. Their fur changes with the seasons, becoming thick and insulating during winter, then lighter during summer. Even their nasal structures are adapted to warm incoming air before it reaches the lungs, reducing heat loss with every breath. Every part of their body contributes to survival in cold environments. Even smaller organisms demonstrate remarkable strategies. Insects, larvae, and microscopic life forms in frozen soil often enter states of metabolic slowdown. Some essentially pause their biological activity until conditions improve. Others produce special sugars and proteins that act as natural antifreeze, preventing cellular damage from ice formation. Instead of resisting cold, they transform how their bodies respond to it. And here, a deeper pattern becomes undeniable. No organism in extreme cold survives by overpowering the environment. They survive by adapting to it, by integrating it into their biology, by making cold part of their life strategy. Fish alter their blood chemistry. Mammals develop insulation systems. Insects reduce metabolic activity. And every species finds a different solution to the same fundamental problem: how to stay alive when everything around them is freezing. When we step back and observe this entire system, something profound becomes clear. Life is not defined by comfort. It is defined by adaptability under pressure. In frozen worlds, life does not stop. It slows down. It conserves energy. It enters states of minimal activity. It waits. And when the environment becomes less extreme, it resumes again, seamlessly, as if nothing had happened. And perhaps the most important truth hidden in these frozen ecosystems is this: even in places that appear completely uninhabitable, life does not surrender. It adjusts. It evolves. And it continues. Quietly. Patiently. And against all expectations, endlessly.